Hello everyone. So on today's lecture number 5 we are going to see about the specific outcome, in particularly chopper fed rice class C chopper. Okay, on the next video you will see the class D, and thereafter we can see class C chopper. So before moving to class C chopper, the continuation of class A and B need to be revised, because combination of class A and B forms class A chopper. So we learned the class A chopper. It's a class A chopper works in first quadrant. Okay, only in first quadrant, because it delivers the power. The power flows from source to load. You can see the diagram. Okay, it consists of a switch connected in series with the load, and parallelly and diode is connected, which forms a freewheeling operation. So this is what class A chopper. And class B chopper is works in second quadrant, and the power flows from load to source. So the current direction is reversed in comparing with the class A chopper. Okay, and in this also you are going to have a switch in parallel to load and diode in series with the load and source, but in reverse direction. Okay, so using these two we can find we can do class C chopper. Okay, before that we can see some problems relating with class A and B, a simple problems. Problem number 1, a chopper circuit is operating on TRC, time ratio control, that is nothing but PWM, at a frequency of 2 kHz on a 460 volt supply. If the load voltage is 350 volt, calculate the conduction period of the thyristor in each cycle. Okay, the problem is given. Try to solve the problem on your own, or try to write the formulas. Okay, formulas relating with class A chopper. Here TRC refers to time ratio control, and the frequency given. We need to find the total time. Total time is nothing but what? T equal to 1 by F, and we know the supply frequency, and we know the load voltage. Okay, probably on class A chopper, what is output voltage? Output voltage formula V output equal to duty cycle into supply voltage. Here we doesn't know the duty cycle. If we know the duty cycle, then we can write we can calculate the T on period, that is conduction period. Fine. So we know output voltage and supply voltage. Okay, using that we can find the duty cycle, with which we can find the final T on time. So the solution is given here. So we find the chopping frequency from the given frequency 2 kHz. Okay, total time period is 0.5 milliseconds, and the output voltage formula, as I discussed, V output equal to duty cycle into V supply voltage. So duty cycle is something but T on T. So using this formula you can find the T on time. T on time can be calculated. It is about 0.38 milliseconds. Okay. Next problem. The input to step up chopper is 200 volt. The output required is 600. Here it is a class B chopper, because output voltage is greater than input voltage. We are going to boost the voltage, and if the conducting time of thyristor is 200 microseconds, okay, we need to find the duty cycle. Okay, because the total time is not known, and parallelly the frequency is not known, we are going to find it. Okay, compute chopping frequency. Okay, the pulse width is halved for the constant frequency of operation. Find the new output voltage. The other question is that if the pulse width is halved, then we need to find the output voltage. Okay, for the first problem we need to find the chopping frequency. Okay, next problem, we are going to reduce the T on to half and we are going to find the new output voltage. Okay, first one, the formula for VDC, V output equal to supply voltage into total time divided by T minus T on. Okay, by applying the values, you will get the time interval T, that is 300 microseconds. Okay, so that we can find the chopping frequency. Frequency is nothing but 1 by T. So the chopping frequency is nothing but 3.33 kilohertz. So we find the first problem. Second one, when pulse width is halved, so our T on time interval is considered to be 100 microseconds. So that is not seconds, microseconds. So when I put 100, fine, you can find the value of output voltage. Okay, on the same formula we obtain the value of output voltage is 300. Okay, simple. So using this you can design your own circuit. So let's see class C chopper. So type C chopper is a combination of class A and class B chopper. So it's a 2-quadrant chopper. First quadrant meant for forward motoring and second quadrant meant for braking. Okay, the following operations is shown here. On the x-axis current is taken, on the y-axis voltage. So class C chopper can perform rectifier operation, inversion operation. In first quadrant forward motoring takes place and the second quadrant regenerative braking takes place. So the load voltage, average load voltage is always positive. That is why and the load current may be positive or negative. So that is why it is said to be in first 2 quadrant. Okay, voltage is said to be in positive, but current is changing from positive to negative. So power flows either from source to load, that is first quadrant, or from load to source, that is second quadrant. Okay, class C chopper used for motoring and regenerative braking of DC motors particularly. So let's see the circuit diagram. So here thyristor T1 and T2, diode D1 and D2 is given. So it combines the class A and class B. When you look into the circuit and when you refer class A and B circuit, you can find the similarities. Okay, here T1 or D2 conducts, the output current and output voltage will be always positive, and chopper quadrant is first quadrant. So T1 and D2 forms class A chopper or first quadrant here, and T2 and D1 conducts. Okay, the load current is negative and the chopper operates in second quadrant. Okay, D1 is said to be making the reverse direction of current. Okay, quadrant is possible. So in this chopper switch, T1 and T2 are turned on off alternatively. Okay, but the switch cannot be turned on simultaneously, so that leads to short circuit. Most important thing in this circuit. Okay, so let me see the modes